Hey, what's going on, guys? Let's do this problem right here. So we have this function right here that is n factorial, and in the denominator we have n power n. Let's see whether this one converges or diverges. For example, if I pick a value for n, let's say if I pick value for n as a 5 factorial, it's going to be 5 times, 4 times, 3 times, 2 times 1. So that's what factorial means, right? So it goes until 1. And if I do this one for like okay, let's see if we have 1, the factorial is going to be just 1, right? 1 over 1. If I pick a value for n, if I pick a value for n, it's going to be 1 over 1. Let's pick a value for n like 2. It's going to be 2 times 2, because 2 square, 2 times 2. Then in the top we are going to have 2 times 1, because it goes until 1, 2 times 1. And if I pick 3, it's going to be 3 times 3 times 3 in the bottom, because 3 cubed, right? And in the top it's going to be 3 factorial, that's going to be 3, 2, 1. If I pick 4, it's going to be 4 times 4 times 4 times 4. In the top it's going to be 4, 3, 2, 1. And if you look at this value, this is 1. And whatever the value, like this is going to be 1, right? But here it's going to be less than 1. So as it decreases, the value decreases. But from the numerical sense, we can't prove that this is converges or diverges, but we have to create a general pattern. So let's create a general pattern right here. So let's bring n factorial over n power n. That's equal to, if I pick n value, let's say n is a large value, and what's going to happen is the factorial is going to be reduced by 1 each time. So it's going to be n minus 1 over n, then n minus 2 over n. So if this is a large number, it goes until like this, until 3, 2, 1, all the way to the 1, right? And here we are going to have n until the end. So if you look at this is 1, right? This n divided by n is 1. N minus 1 divided by n less than 1. Because this is less value divided by bigger number, it's going to be less than 1. And it's going to be reduced and reduced until it's going to be reduced until the end. So we know this is less than 1. Less than 1, right? Less than 1. And it's going to be less, right? It's going to be less until the end. So this pattern is going to be in the decreasing pattern. So that's how it's going to go. So let's pick up these two values and see whether these two are converges or diverges. And we know from this one this definitely converges, but to prove this one, let's pick up these two values and see. So let's pick up this value. So 2 over n times 1 over n. I'm picking n factorial over n power n, applying this to this. So that's going to be 2 over n square. And we know whenever we have 1 over n power p, if the power is greater than 1, this is converges, right? This converges. And if the power is less than 1, that diverges. Less than or equal to 1, that diverges. So according to this condition, if you look at this is greater than 1, therefore this diverges. So it proves that this pattern diverges. So we can know this is greater than 1, so it converges, right? It's greater than 1, so it converges. So from this one we can prove this whole thing converges. So that's how we prove these things. I hope you guys liked this video. See you next time.